So yeah, today we are solving the problem POTD problem design min max q, which is in my view problem difficulty medium true. In this, we will have two supporting queues. So let's solve it now. Okay. So yeah, we are required to design a special queue data structure that functions like a normal queue, but in addition to in addition, um, we need to also put in the functionality of it finding minimum and maximum element efficiently, so that it may consume about O of 1 time complexity. So the get front deque and q, these are simple functionalities, we are all familiar with it. Nq, it is a simple queue in which we push in from behind and pop it from ahead, and in deque we can pop it from front and back both as well. And get minimum element, we need to perform that in O of 1 time complexity, and get max also we need to perform in O of 1 time complexity. So this is the difficult task. Other than that, everything is pretty much simple. um, the difficult thing is like getting min and getting max in that constant time complexity. This can be done if we will use two supportive queues, like I have declared here, min deque and max deque. These two supportive queues will be very helpful in our scenario, because what we will be doing in this is, whenever we are pushing in, like we are pushing, yeah. And another thing, like we have been given a list inside a list, we are given an nested array basically. So if we are the first element will be the first element of the sub queue, sub list or sub array, um, will be the command. One stands for nq, basically pushing in. Two stands for dq, basically popping out. And three stands for um, get front, getting the front element which is present in the queue at that point of time. Like if here it is 3, we need to find out the front element. And here it is 1, we need to push 4 into the main queue. And 5 is equal to get max, and 4 is equal to get min. So here we have given those commands, and 2 is equal to dq, basically whatever the element that is there in the front of it, we need to pop it out. So yeah. Okay, that is clear. Yeah, so we are using two queue. One is min deque, and the second is the max deque. So what we are doing in case of min deque, so um, if whatever element, if the deque is empty, basically we will just push in the element, we will push back the element. uh, and if there is some element already present in the deque, we will check if it is greater than that of the current element that we have encountered, or we are trying to push into the main queue, or it is greater. If it is smaller than that of the element already present in the min deque, we will just pop that element, and we will push the element that we currently stand at, that we are pushing into the main queue. And same in the case of max. We will check if that element, if the first we will check if the max deque, the queue that is basically responsible for storing the greater elements, the larger elements, in a sorted format, if it is empty or not. And second, we will check if the last element that is present in the queue is smaller than that of the element that we are currently pushing. So if it would be greater than that of the element that is currently present at the back of the queue, we will just pop that element out, and we will push in the element that we currently have. uh, so yeah, we will push back it. And in the if we get a command to deque, like if there is 2, if we are given 2, like in here, in a sub array, what we will be doing, but we will be, first of all, we will be popping out the value that is already there. Yeah, obviously. First we will uh, store that value in a particular variable, so that we can check it ahead. And then we will just pop it out from the main queue, which is queue. and then we will check in the min deque if it is empty or not empty, and we will check its front. If the front of it is equal to the value that we have popped out of the main queue, we will also be popping it out of the min deque. And if it is there in the max deque, we will also popping it out from the max deque if the front element of it is same as that of the front element in the main queue. And what if we may get some other command like get front? If we are getting get front, we will just return the q dot front. We don't really bother about what is there in the minimum or maximum deque. Will just return the element in front of the main queue. uh, and if we are given a command of getting the minimum, then we will return the element in the front of the minimum queue, min deque dot front. um, we are basically returning the value that is there in the front of the queue, which stores the minimum elements, the small elements in a sorted format, uh, smallest element. And the get max function also, we are doing the same thing. We are just returning the element in front of the queue that is storing the maximum, the larger numbers. Basically you can basically you can look at this problem like we are having a line of students, and just a hypothetical situation, we are having a line of students and that is all jumbled up, like we are not, it is not height wise or anything. So what we will be doing is, if a new student comes, like first the line is empty, a new student comes in, we will put him into the main line, we will put him into another line which is the minimum line, storing the uh, sorry, in which the students are standing in a line in an ascending format based on height, and maximum line in which the students are standing in a descending format. So if a new student comes in, if its height is smaller than that of the student already present in the min line, we will just pop that student out, push in the new student, then in and same we will be doing in the max line. We will just be um pushing it because the student that is already present is taller than that of the student that is just being pushed. So that sort of sums it up. Now let me just try to run this. Yeah, submit. It should satisfy all the test cases. Problem solved successfully. Time taken is 0.02 time complexity, and it's my second attempt. I've already solved it once. Um, yeah, and sorry for this late POTD. I have been busy for some time now. Yeah, thank you.